All right, homework 9 is day 1 of nonlinear systems. So nonlinear system is just a system where one or more of the equations are not linear. So they might be quadratic, a circle, an ellipse, hyperbola, etc. Just at least one of them is not linear. That's basically all that it means. So we're going to solve for this first day by graphing, which literally just means graphing them using every method that we've used so far and then finding the intersection points. There could be one, there could be multiple solutions, or it's possible that there aren't any because they never intersect each other at all. So let's take a look at number 1. So you have, just based on what you've seen in context so far, this first one, only one of the variables is squared. That makes it a parabola. The second one, neither of the variables is squared. That makes it a line. So you're going to have a parabola and a line. Again, they might intersect each other 1 or no times. The max is 2 for a parabola and a line. So we're going to use the methods that we know so far. So we're going to start with this first one. Actually, you know what? We might as well go with the second one. Lines are super easy to graph, so we'll start with that one. So x minus 4. We have a y-intercept of -4, and then the slope is 1. Normally, you just do 1 or 2 points and then connect the dots, but here the entire purpose is finding the intersection point. So you want to make sure your graph is incredibly accurate. So when you do up 1 to the right 1, you are actually going to continue that pattern until you run out of grids. Okay, and then you can go backwards, just reversing that pattern in the other direction, because you need to know exactly where these graphs intersect each other, so you want as many points as possible. Okay, next we've got the parabola. So this, when you do a parabola, the best thing that you can do is find the vertex. So the vertex, remember our formula is negative b over 2a, so -6 over 2 times 1. So this is a -3. We use that -3 to create a table and kind of center where all the points are going to be. So set up a little xy point. So we put -3 in the middle, and then we go back a few points, we go forward a few points. And this is something that you could absolutely feel free to just plug in to a calculator. So I'm going to show you, you could either plug in the points one by one, that works great, or you could plug the points into Desmos, create a table. I'm going to show you that second option. So make a table in Desmos. You can make this just x, and then in place of this we will type in our function, so x squared plus 6x. It's going to show that little caution sign until you start plugging things in. So -6, the y value is 0, -5 is -5, and then it's going to start to predict. So -4, -8, -3 is at -9, and then remember this was this was the vertex, so they are going to start to repeat back like that. Okay, so we can plot those points, connect the dots, and then we'll have our parabola. So -6, 0, we have 2, 4, 6 right there at 0, -5, -5, -4 is at -8, so there's one intersection point right there, -3, -9, and then it mirrors, which gives us our second intersection point right there. Okay, so connect the dots. Accuracy is what counts here. So our solutions are these ordered pairs. So this ordered pair, that was this one, and then this ordered pair right here, which was this one. So our solutions are -4, -8, and our next one we found was -1, -5. Okay, so just accuracy is the name of the game here, and then you are looking for intersection points between the two graphs. So let's look for one on the next page. Let's find something that's not just parabolas. How about, number 11 has a circle down there. Let's take a look at number 11. This first one is a circle. It's in standard form. It's perfect. It's ready to go. So the center of the circle is -1, -4. So we can start there. And then the r squared is 4, so that means the radius is 2. So from this point, we can go 2 units in all directions from the center. Go ahead and connect the dots. So you've got that. We want to make sure it's super accurate. And then this is a parabola, so we're going to do the exact same thing that I just did for number 1. So find the vertex first. So -b over 2a. So -2 over 2 times -1. So -1 becomes the x coordinate of the vertex. So we're going to set up a nice table with -1 in the center. So go back a few units, go forward a few units, we'll plug half that table into Desmos and then just know that it's going to be mirrored. So I'm going to add another table. So this one, again, just the x coordinate there, and then plug in this equation. So negative x squared minus 2x minus 1. So we need to plug in values in order to see the y. So negative 4 is negative 9. Negative 3 is negative 4. Negative 2, whoops, it guessed for me and I deleted it. Negative 1, again, negative 1 is at 0. And then it is a parabola. It's got symmetry. So after that vertex, it just mirrors itself back to the other direction. So let's connect the dots here. So negative 4, 1, 2, 3, 4. You know that's not going to be it because it's past the circle. Negative 3, negative 4. There it is. So that's one of our intersection points. Negative 2, negative 1. Negative 1, 0. And then it mirrors itself back. So that would be the second one. The 1, negative 4. And then here's the rest of it. So our parabola goes up through that intersection point, back down through the other one. So you've got two solutions. It's these two ordered pairs. So we have negative 3, negative 4, and we also have positive 1, negative 4.